Welcome back to the lab. Today is indeed another great day. So today I have something to show you. So I have this table lamp here that I made from the bulb I converted in a previous video. So I attached it to this arm here. This was a phone holder. I clamp it on the table like that, and then my bulb is hanging on the other end. So the issue with this thing is that it's so bright in such a way that whenever I decide to use a laptop on this table, the reflection from the laptop screen, it's really affecting the usability. So what I need to do is that I need to come up with a way of lowering the brightness on this, and maybe when the need arises I can crank the brightness up. So the brightness on this is good, especially when I'm shooting a video like this. You can see, you can be able to read the tiny details. So the only issue is whenever I decide to use a laptop here, so the reflection, it's really affecting the working. So I have two approaches for this. I need to make a control circuit. So, and the two approaches I have here is I can build a PWM control circuit, that is pulse width modulation circuit. I can use something like a 555 timer, the 555 timer IC, or I can use a buck converter to maybe adjust the brightness by lowering the voltage. I can also maybe use an adjustable linear regulator. So the PWM is the most efficient way of doing this. The issue with the PWM circuit is that whenever you lower down the brightness, there might be some flickering. You might be seeing some flickering on the video due to that action of the PWM switching on and off. So I want to try out a linear voltage regulator, and maybe later we shall build a PWM control circuit. So I have a LM317, which is an adjustable linear voltage regulator. Let's see if we can achieve the goal with it. And I think since this bulb is only 24 watts, and maybe right now it's drawing like 15 watts, so the LM317 will be able to provide enough current for the bulb. So that is the solution I have. And now stay tuned and let's get started. So the first thing you need is your linear regulator, and here you have it, the LM. I don't know whether you can be able to see the numbers. So the LM 317. So 317. So we also need two capacitors. So I have one ceramic and one electrolytic. We also need a 220 ohm resistor, and we also need a potentiometer. So this is a dual potentiometer. So we have two lines. So we are going to, I have 50 kilo ohms. So we are going to connect these lines in parallel, so that we can get a 25 kilo ohm resistor. We're also going to need some prototyping board like this. A small piece will be enough. So let's see how the circuit will look like. So for your regulator, this is the pin out. So this is pin 1, pin 2 and pin 3. So input, then output, then adjust. So pin 1, pin 2, pin 3. For our circuit, it will be like this. So here will be our output, pin 2. So that is our 317, and here we are going to get our input, that is pin 3, then our adjust, which is pin 1. So we are going to connect our resistor here. Our 220 ohm resistor will be between the output and the adjust pin. Then our potentiometer will be, so we shall have our ground here. Our potentiometer will be between the adjustment pin and the ground, like that. So we are also going to connect our capacitor here. So this is our electrolytic capacitor, and we are also going to connect the other ceramic capacitor there. So this one will be our input. So this is the ground or the 0 voltage point, and here will be our output. So this is pin 2. Our load will be connected between our load, which is the bulb, of course, will be connected between the output and the ground. So this is the input voltage, the output voltage, and then we can be able to adjust the voltage, the output voltage, using this potentiometer here. So let's go ahead into building the circuit. So I want the potentiometer to be at the end of this board in case we ever need to mount it somewhere. So let it be there. So we need to join these two. Like that. So this will be our ground. Then we need to, okay, pin 1 needs to go here, like that. I think it's well soldered in place. Then our 220 ohms resistor needs to go between, as per the circuit, between pin 1 and the output. So I'm going to leave a space here in case we need to mount a heatsink, of which I don't think we need. So I can give a space like that. Let me see if I have a small heatsink. I'm talking about a heatsink like this. So like this. Of which maybe it's a good idea we use one, but I don't think we are going to draw that much current to a point that we need a heatsink. But since we have one, let's just use it. So like that, in case we need to reuse this circuit for some purposes that may require more current. So our pin 1 or the other one, our resistor needs to go between the output like that, like that. So this is our output capacitor that needs to go between pin 2 and the ground. So the ground is around here. So here is the ground. I'm thinking we should make sure that our capacitor is as close as possible to our regulator. So I'm going to set it here like that. So our pin 3 is here, and then our ground is here. See? Perfect. So like that. We also are going to need to connect the ground of this capacitor to the ground of our main body. Maybe we can tin these lines, the output and the ground, so that they can look nice like that. The output is this pin, so this is ground. So the lines are well tinned, so we need to have a jumper between this and that. Then underneath, yeah, like that. Now our circuit is done. So what we need is our wires. So we also can so this is the why is there, this is the output, input. We can maybe make our circuit more appealing. We can move our output to add this area. So as to avoid short circuiting. So we can move our output to here. We can do a bridge here like that. Then we can remove this part by just overheating it. Let's see whether we have some short circuit. No, we don't. Our ground is okay. So this is our output. Then our input. Let's solder some wires and do the testing. The red is for the positive. So this is our out. like that. We can use some hot glue to make sure that the connection is okay. Now let's go to the testing. So I'm going to use this charging brick, 19 volts, and I can use another one of these bulbs that has undergone the same conversion. So let's see, it's good we monitor the voltage. So the minimum you're getting is 1.2. You can start adjusting. So the issue with this bulb is that it starts operating at around 10 volts to a maximum of 13. So you have a very small, if you are going to use voltage regulation to control the brightness, you have a very small window, very small range of voltage, 10 to 13. So as I've said, it's not the most efficient, it's not the proper way to drive this, but it should work. So you see, from 10 it's a least you can get, then you can increase the voltage to 13, which is the maximum for bulb. Then you can lower down, you see. That's how it's supposed to work. So for controlling LED, you should find a proper driver circuit, but this one will serve me for a while before I build a PWM circuit. So maybe later we are going to do a PWM circuit. So let me go find a 5.5 timer and some MOSFET. So see you in the next video.